I'd like to put out some more DNAT information if I could. I didn't really like that last drawing I did. It was terrible. It was just ridiculous. So I did a little bit of same principle, same concepts, but a little more information on this particular drawing here. When we were talking about DNAT on the last video I did, I just wanted to point out in this configuration how I was set up. Basically, I'm on the external side of my router, wide area network side. I'm hitting port 192.168.1.119 through Ethernet 0, and then I'm using a DNAT to get me to the router firewall. I'm looking at the firewall rules, and then it's putting me through to Ethernet 1, and I'm actually hitting this workstation here. So that's pretty much how DNAT works. I put some more logic down here. Hopefully this makes sense. Basically, we're talking about the DNAT translation when it first hits into the ETH0. And this is like the criteria of what you apply to it, and this is what we currently have set up. So obviously, when we go to the source IP, we're allowing any or all source IPs. That's basically the from IP, or in this case, my 1.124 address. And then we're going to do the destination / translation IP that it's going to translate to, the protocol, and the port that it's going to hit. Okay, so once it does the network translation, it goes and starts working on the rule sets and the actual firewall rules that go in. So again, this is more like the rule set criteria, name, description, all that. This is how we currently have this one set, where we've got a wide area network in that was automatically created when we did the basic setup. And then this is how we have everything set. Basically, the name is WAN in, description is WAN to internal. The default action is dropped, which I believe creates this particular rule over here automatically. The interface that we're going to be dealing with and the direction that the packet's going to be going. So after you do a basic setup, it gives you these first two rules, and I believe that the drop rule is also in place. When we created DNAT, we created this rule number 21, which is the next rule over. So again, when we're looking at the individual rules themselves that are part of the rule set, this is the criteria for that, and then this is how we have it set. We're going to allow RDP as the description. The action is to accept the packet, as long as everything is correct. I would imagine that probably accept is down below, but it's going to check for TCP UDP. The source is going to be all IPs. The source is going to be all ports. We don't care where it's coming from. We just care where it's going to. In this particular case, I have the destination IP set so that only this traffic is going to be allowed through to this particular box. That was that warning that I talked about the last time. So I have it set to 10.10.1.1.24, and again the destination port is RDP 3389. Once the traffic gets into the router, it goes through Ethernet 1, and then out to the workstation up here. So I hope this makes sense. This probably isn't the exact flow. I'm kind of guessing and assuming a lot of this. There may be a router function that takes place over here in between the NAT and the actual firewall examination of the firewall rules or whatever. But on the flip side, when you're sitting on one of these workstations, actually this particular one, since we're going to ETH1 and going out, the process is a little bit different because we don't have any rule sets set up for the outbound traffic. All we have is a masquerade NAT set up. So basically, from what I understand how this works, is we go through the router, it's going to route it, and NAT's going to kick in. We're going to NAT address translation the packets as they go out, and they're off to the internet or wherever it needs to go. Okay, enough about DNAT. So now what I want to do is I want to talk about port forwarding, and basically port forwarding is just about the exact same thing as DNAT, except that when you're doing a port forward, you're using the default IP address of the device. So the default is now going to start listening in on a particular port. Again, we're going to use RDP. But in this case, what I'm going to do is I'm going to set up a port forwarder to forward all traffic coming in on port 3389 RDP. It's going to go through the firewall into, this time we're going to go into ETH2, and we're going to go to this box here, Win10 Test 2, which is on 10.10.2.28. So let's go ahead and do that real quick. I'll show you how to set that up. All right, so we're back in the router. We're going to go over to Firewall NAT, and in this case, we're going to set up a port forwarder. It's pretty easy. The interface that you want to use, in this case, we're going to use ETH0, so that's the incoming interface, and then we're going to add a rule. And the originating port is going to be 3389. We want both protocols, since I do believe UDP has both. So we're going to forward to address 10.10.2.28. And again, the address that we're going to forward to, and the description, we can just say allow that, and then just change that to 2 instead of 1. And then we're going to hit apply. Great. So we now have a configuration has been successful, so we should be good to go. So now we have a listening port on our main Ethernet default address of 192.168.1.118. So I'm just going to go ahead and connect to the external default port of the Edge router, and I'm going through. Going to put in my password. And I'm in. Alright, so let me go ahead and stop this. Just wanted to also show you guys a little bit of Wireshark stuff, a little bit of traffic going on. You see where I'm coming from. So if we go back and we see the IP address of the source is 192.168.1.124, and we're hitting 10.10.2.28. This is the port I'm coming from, and if you remember right, remember what I said, the source IP and the source port, we don't care. We're going to allow it all through, so it doesn't matter. So whatever this particular port is coming from my PC on the outside, it just does not matter. And we're hitting port 3389 on this IP address. And basically, this is the start of the RTB session. It goes all the way through. We end up with data, and you can see it just going to town. And as you can see, some of this it does indeed use UDP and TCP, so you got to have both of them enabled. You see the traffic. So I just wanted to show a little bit of Wireshark capture on what a connection would look like on this, and there's basically not much more to tell. Let's go back and look at the drawing real quick, just to. Alright, so again, port forwarding, we're using the default IP address coming from this device here, through my switch, through my router, through Ethernet 2, and then hitting this device here where I had that Wireshark session running so that it would actually pick up that traffic. It's a very similar setup as you would have here, the way I have it set up here. But like I said, this router right here, I'm not sure if there's a router that actually needs to be shown here or not. If somebody else knows more than I, they might be able to chime in on that. If I look at the other document that I have, that's a training document, it does kind of show that you go through the network address translation, and then there's routing that goes on before it actually hits the firewall. So I'm guessing that it's going to just look at whatever IP address is that it's translated to, and then it's going to route to the proper firewall for that. But I would think that if it was firewall in, it's really only set up for ETH0 before it even gets anywhere else. So I would imagine that there's some other routing going on this side as the packet goes out, like I show in my diagram. That's just conjecture on my part. I don't know if that's 100% true. And again, I don't know if this is 100% true. But one thing that I do like to do is I like to map out all of my firewall rules when I do this. Put them in a spreadsheet. Show them, where it's coming in at, where it's going, what it's doing, what ports are open, so that you can just basically look at your firewall order and see if there's any conflicts. See if just to see what's going on. If you've got any overlap that you can try to combine together, and maybe come up and start making some groups of ports or groups of IP addresses or things along that lines, because it looks a lot better when you don't have too many rules. If you just have a few rules and groups that actually group everything together and allow stuff to go through, it's a lot easier. All right, well, I think that pretty much wraps it up for this video. I hope this all made sense, and I'll see what else I can find to do. Thanks for watching.